All right, let's try to finish up here the introductory 2.0 with limits and some calculus here. If you remember, what we were talking about before was we ended the last one with the limit as x approaches 0. We said of 1 over x, we said it doesn't exist because the limit does not go to the same spot, right? From the left, it goes to negative infinity. From the right, it goes to positive infinity, and since they don't go to the same place, we said the limit does not exist. Finally, we remember if a limit goes to positive or negative infinity, if you remember, we have an asymptote there. If you remember how 1 over x works, right there down the middle, there would be an asymptote, a vertical asymptote right there at 0. So, point is, as remembering this, we have the asymptote going straight down the side. We have to remember what that in turn means as we're going through the problems. But the other item here that I wanted to point on, just so we are aware, right here. As x approaches 0, right? As x approaches 0, as you see, there is no limit of 1 over x. But what you guys also need to grasp, though, is what if I said as x approaches 1? Well, roughly we'll just say here's 1. Does the limit exist at 1? The answer is yes. The limit does exist at 1. Because if this is where it would cross, if this is 1, we'll just say, and I go up, the limit exists from the left and the limit would exist from the right. So what sometimes people have a hard time grasping is when you see this, you just assume, oh, well, the limit doesn't exist. Well, that's not the case. What the limit goes to depends, all right? As x approaches 0, the limit does not exist because as x approaches 0, it goes to negative infinity. As x approaches 0 from the right, it goes to positive infinity. So it doesn't exist, right, at 0, but the limit would exist basically everywhere else. It exists at 1, it exists at 2 or 3, it exists at negative 1, and it exists at negative 2 or negative 3 because from the left it would exist here. From the right it would exist here. So we have to understand that just because we're saying it doesn't exist here, it doesn't mean it always doesn't exist. What it actually means is it doesn't exist at 0. Right, and things to think about before we move on into section 2.1, just some items to think about. Imagine if you plug the 0 in. If I plug the 0 in the denominator, I get 1 over 0. You can't have 0 in the denominator. You can't. It's just something to think about. But I can plug in a 1, right? I can, like I said, plug in a 1. I can plug in a 2. I can plug in a negative 4. Like all those would work if I plug them in. As x approaches negative 4, it would work. So just something for you to think about as you're going through this. And we'll kind of clue in on some of this stuff when we really start up limits here in section 2.1. The whole idea with this whole section prior, the main idea, the main focus, was just to give you some background information about what calculus is and to give you a nice introduction with how limits are even found with some graphs, plugging in numbers, things like that, using tables, just some basic background information about limits. All right, so I hope that this kind of gave you an easy, simple little background about what limits actually are. In the next section, 2.1, we are really going to dive in to how to solve limits and maybe even possibly find some properties that we might be able to use, because as you can see, we're not going to want to continue to where was it at here, plug in graphs, things like that. So for example, we're not going to want to do this every time, right? You're not going to want to continue to plug in a graph and keep substituting numbers in every time. Plugging into 1 over x, not a big deal, but as you can see from problems that we had earlier, using tables to plug into a problem like this, do you want to keep plugging in values on either side? No, it's going to get a little ridiculous. And some of you, for that matter, might even have seen a pattern, all right? Maybe you haven't yet on what you could possibly do to find limits. But Anyway, I hope that this was helpful to kind of get you some background, and I'm thinking we can chug right along with 2.1.